This is our lesson on elimination. Elimination is our final method that we're going to look at for solving a system of equations or determining the intersection of two lines. So our first problem here, we have the equations x plus y equals 4 and 2x minus y equals 8. And for elimination, what we're going to do is we're going to combine the two equations. And what I find to work easiest is to be able to add them together. But in order to add them together, we need to have two variables, one in each equation, that are the same with opposite signs. Same coefficient, opposite signs. So for example, in this problem, we have a positive y in the first equation, a negative y in the second equation. If we add those together, they cancel each other out. So that's what we do. We have x plus 2x is 3x, y and negative y cancel each other out. 4 plus 8 is 12. So we have 3x equals 12. We divide by 3 and x equals 4. We take that 4 and we plug it back into one of these equations to solve for y. So if we plug it into the first equation, we have 4 plus y equals 4. We subtract 4 from each side and we get y equals 0. So our answer is 4, 0. And we can check that by plugging it into the second equation. 2 times 4 is 8, minus 0 is 8. Won't always be that easy. Sometimes you may have two equations that look like this. 2x equals 3y plus 4, and x minus 2y equals 7. Well, the first thing we'd like to do is have both of these equations look similar. So get the x's and y's both on one side. So subtract 3y over, we get 2x minus 3y equals 4. But now, as you can see, we have a 1x and a 2x, a negative 2y and a negative 3y. We're going to have to multiply one of these equations by something so that one of our variables cancels out. I chose to multiply the x minus 2y equals 7 by negative 2, so that I'll have a negative 2x to cancel out the positive 2x. So x times negative 2 is negative 2x. Negative 2y times negative 2 is positive 4y. And 7 times negative 2 is negative 14. Now, the 2x and the negative 2x cancel each other out. Negative 3y and positive 4y leave us with positive 1y. And 4 minus 14 is negative 10. So we have y equals negative 10. To find our x value, then, we go back and we plug it into one of these equations up here. I chose the first equation. So 2x equals 3 times y, 3 times negative 10, plus 4. 3 times negative 10 is negative 30, and negative 30 plus 4 is negative 26. So we have 2x equals negative 26. Divide by 2, and x equals negative 13. So our answer is negative 13, negative 10, and we can check that in the second equation. Negative 13 minus 2 times negative 10. 2 times negative 10 would be negative 20. Negative 13 minus a negative 20 would be negative 13 plus 20, which is 7. And here we have another example where, possibly even more difficult, we start out with 2x plus 4y equals 5, and 3x plus 5y equals 3. Notice the coefficients are not the same on the x's or the y's, and we can't multiply 2 times a whole number to get 3 or 4 times a whole number to get 5. So we're going to have to multiply both equations. And one easy way to do it is just to multiply by whatever value, whatever coefficient you have in the other equation. So if we've got a 2x here and a 3x here, flip that, multiply the top by 3, the bottom by 2, and since we want one of them to be negative so that they'll cancel each other out, I just chose the bottom to be a negative 2. So 3 times 2x is 6x, 3 times 4y is 12y, 3 times 5 is 15, negative 2 times 3x is negative 6x, negative 2 times 5y is negative 10y, and negative 2 times 3 is negative 6. Now the x's cancel. 6x and negative 6x cancel each other out. 12y and negative 10y leaves us with 2y. 15 minus 6 is 9. 2y equals 9. Divide by 2, and y equals 4.5. Plug that back into one of these equations. I chose the top one. 2x plus 4y, 4 times 4.5, equals 5. 4 times 4.5 is 18, so 2x plus 18 equals 5. Subtract 18 from each side. 5 minus 18 is negative 13, so 2x equals negative 13. Divide both sides by 2, and x equals negative 6.5. So our answer is negative 6.5, positive 4.5. And we could plug that back into the second equation and check to make sure that it works.